Hi, I'm Teemu, and I wanted to quickly share with you a thing that I'm excited about today. I've worked with MMMs for a while, so mixed models, and after fitting the model, one question that follows this is that okay, what would have happened if we had changed our marketing budget? Another thing that often clients have asked me is that could we somehow model also causal structures within our marketing channels? Here I'm using an example of a marketing mix model with a marketing funnel implemented in it. So in addition to having just a direct effect estimate for some marketing channel, for example, this could be an email campaign targeting past customers, which quite quickly converts to sales. But in addition to that, I have a brand awareness campaign on the upper funnel, and then some paid search channel, lower funnel channel, where this upper funnel activity increases your demand, effectively lowering the CPM, so cost to acquire clients, on the lower channel. So the effectiveness of this channel depends on the other channel. In addition, to keep the model a bit more interesting, I've added a control variable, inflation, and some time varying intercept. So there's just baseline sales that are time varying. We don't really want to explain, but we want to model those anyway. We expect that there's some slow time varying baseline sales. Here I'm modeling those with a Gaussian process, which is a bit of a complex baseline, but a very powerful one. Here's my example data, mostly for demonstration purposes. So this is the synthetic data and a implementation of the model using PyMC. Now, after I fit the model and I've checked some key KPIs, for example, saturation curves, I would be interested to know how do these change if I change the budget. Of course, normally in a marketing mix model, if you just have direct channel estimates, these don't depend on your spend. It's just what depends on your spend is just where are you on the curve. But now that I've modeled also the funnel, where the upper funnel spend also affects the lower funnel spend, we see this effect where changing the spend on the upper funnel channel also changes the spend effectiveness of the lower funnel channel. And this is one of the key points where you get power from including these funnel effects into your models, because otherwise often what happens is that these lower funnel channels get over attributed because some of the effect that your upper funnel channel has is effectively attributed to the lower funnel. You can't see directly what's happening with the upper funnel awareness channels. You know your spend on the lower funnels, and suddenly you see a lot of more traffic directly that you can directly attribute to the lower funnel. So often these attribution models then overestimate the contribution of the lower funnels. But here I see how this shape changes, and I still keep my uncertainty estimates with me that I gained from fitting this Bayesian model. That after fitting I have 2,000 posterior samples. Here I'm using 500 of those, but what I have done is I've created a function to take the back end of the model, optimize the graph. I just tell that these three channel budgets are the inputs that I'm interested in. These are the things that I can actually affect. These responses are what I want to see changing based on the inputs. And I've told PyTensor to just optimize everything else away from the graph. So keep that as constant. Not just constant, but I've handed it the whole posterior sample set. So still for example, the time varying baseline, I have an estimate with uncertainty included, but I'm not resampling that. So this gets very fast. As you can see, the computation for the lower funnel channel happens pretty much instantly. I'm running this on Marimo, so this is an interactive notebook that you could, for example, host as a dashboard for your stakeholders. Another interesting effect is response curves. So instead of looking at the saturation just directly, the direct effects of your channel, we can think that, okay, what is our estimate of the total contribution of this particular marketing channel over the whole time period that we have modeled, or some given time period. So here on the x-axis, I have the total spend over the whole time period. Y-axis is the estimate of the total contribution. And again, I can be scaling the spend down. So here I'm keeping the spending pattern the same, but I'm just scaling the absolute spending up or down. And I can see how changing the scaling or the spend of the upper funnel also changes my estimate of the contribution of the lower funnel. I can also take away the uncertainty estimate, making this a bit clearer, but you can see how the saturation curve shape changes. And finally, what can be exciting to look at, and what is possibly interesting for, and definitely easy to communicate and understand for your stakeholders, is that what happens to the sales. And here, this is just the time series that I fed to the model, these black dots here. So these are the observed sales. And now I can answer a counterfactual. So what happens if I do this instead question, where what would have happened to my sales if the sales would be higher or lower? And here we can nicely see how there's some saturation happening. So when I increase the sales very high, the spend very high, the sales don't pretty much anymore increase. And you can imagine that the next step with Marimo and this kind of interactive dashboardy thing could be that we could have here, for example, a bar graph showing the actual marketing spend for this channel, and I could be pulling those bars up or down and instantly seeing like how this hypothetical spending pattern would have translated to sales. I think this is very powerful, and it makes essentially interrogating your model after fitting very interactive and easy to communicate. And you can give this to other people, not necessarily as technical, and let them also play around with your model. And this is all running just on my laptop locally. So this is really computationally much lighter than resampling the posterior predictives. Yeah, I hope you're excited too. I'm very excited today.